just want some footage for...
Hey guys, welcome back from Classic Work. I got a good little project for y'all today. This is a hub off of some kind of agricultural seed cultivator, something or other combination. I'm not exactly sure what it is. The guy brought it to me, he told me, but I done forgot all about it. But if you can tell, this shaft has got a pretty good taper in it. And it's supposed to be 2" all the way down, and if you can see here, she lost about ½ an inch. Something put that one on slim fast. But anyways, these are actually pressed into this cast hub here. You can see they go all the way through. But I tried getting one of them out, and that son of a gun didn't move, and I did not want to risk busting that housing. So what I've done is, on these two, I've actually fixed them. I've welded these completely up and then turned them back down. So they're sitting at 2" now, if you can see. Yeah, it's showing less, but it's not, I promise you. So anyways, both of them. So the way I've been doing it, I have a lot of people still ask about the old rollout wheel here. I haven't showed it much in any of my other videos, so I'll just show you a little basic on how everything works on it and how it does all of its good stuff. I have a lot of people comment about the last time that I used this. They all asked, hey, are you grounding through the bearings in the hub? And you can see plain as day the ground is going straight through the bearings. Okay, I haven't had any issue yet. This thing's welded up a lot of stuff. Eventually I think it will arc them up enough so that they'll be grinding, but you can hear it. It's not, I mean, it's still smooth. There's not any, there's a rough spot in there every so often, but it's nothing major. So it'll go as long as it'll go, and when the bearings tear up, that's one reason I got a universal hub, is you can change them. It's easy as that. But yeah, so this one here, I'm getting ready to turn down on the lathe. There'll probably be some low spots in it yet, so I'll probably have to fixture it back up and fix any of the low spots. But I'm going to show welding this one up and turning it down, and should be good, so stay tuned. So if you're new to the channel, this is a rollout wheel, is basically what they're called. It is a mechanical weld positioner, is basically what it is. Where most weld positioners use electric motor to turn, you turn this one by hand. That's why you see this gear looking thing over here on the left. If you're interested in something like this, I got a video that I made several years ago. I'll put a link down in the description where you can find it. Don't go solely on how I did it, because I would have changed some stuff on this. It was my first time to ever build one of these. And if I ever build another one, I'll probably make a video of it and build it right. But anyways, this worked for what I needed it to, so let's get after this thing. So we've got a 3-jaw on here. Nothing fancy. These parts fit really good on this jaw. There you go. So we're going to go ahead and clean up the edge here. Easy peasy, nothing to it. And there's a couple of different ways you could build this up. Probably the most economical is actually just plain old MIG weld. MIG welded. A lot of bore machines and stuff like that use the same process. We'll be using ER70-6, I think is what is in the machine. I don't recommend doing this with stick unless you know what stick process or what rod that you're going to use. For instance, I have built some up with 70-18, and you're going to break your carbide trying to cut through that. I don't know why 70-18 is so hard, but from my experience, it's been tough. If you do decide to build one of these up with stick, I recommend you use like a 60-13 or a 70-14. I have used those in the past to do a job like this, so those would be pretty decent rods if you can't use a wire feeder for whatever reason. So just a little insight on that. But yeah, do not use 70-18 on these because you'll have a hard time cutting through it. But yeah, so we'll get started here. Okay, so basically most of the wear is up here towards this end. So you want to concentrate most of your welding up here because that's where most of it's going to get shaved off anyways, or the least amount is going to get shaved off, what I meant to say. So what I do is, I know this is going to sound stupid because you can sit here with one hand and sit here and weld it, but I've had real inconsistent weld bead patterns. So what I do is I actually go around the rim first and kind of build it up, and then I'll actually strike lines off this way and then weld across them more or less. Try to get kind of like a cross pattern. It seems to do pretty good whenever you get ready to cut. So let me quit jawing. Believe that? Ran out of wire on the last stage. Anyways, you kind of get the idea. You just finish all that up, you let the part cool off a little bit, and then you can start working from here back. And then you clean it up a little bit, put another pass on it. So it's pretty simple. I got to change some wire apparently. Alright, so I welded a little more off camera. You can see it's smoking pretty good there. My wire feeder kept screwing up. I had to clean my tip a couple of times, and thing was doing perfect till I changed that wire. I don't know what happened. And yeah, tip got a little screwed up and it wasn't letting the gas flow in the right places, and yeah, but that's pretty much, you know, pretty decent though, you know, out here on the end. We'll clean all this up though and it'll look just fine. But if you can tell, you know, if you want to rotate it, you can, but I can't get as consistent as I can running this way. You wouldn't think they would work like that, but it works really good. That's the best way I found to do it. But anyways, we're gonna let this cool off, and then we'll hit the high spots with a grinder, and then come back and put another pass on it. And while that is cooling, we're gonna go over to the lathe, and I'm gonna show you what I got. So I got my 3-jaw chuck on here, chucking the exact same way that the rollout wheel is. And basically I've hit all the high spots down. I'm not exactly sure where the center is on this dude, but we're gonna find it pretty close. So if you can tell, she's got a little bit of run out, but it's not as bad as you would think. But we're gonna go from there. Alright, I don't know if you probably can see that from there. You can see the low spots in this shaft. We've turned it down. I've left it about 30 thousandths oversized so that we can have a good cleanup when we get all these low spots filled back up and turn the high spots back down. So, yep, that's basically you're gonna have to hit them twice unless you're really consistent as a welder or you build up oversized, like big time oversized. That's how you do it. So I'm just going to hit a couple of places and we'll let it cool and put it back in the lathe. Do it again. Well, there you go. That's the girl right there. Turned out pretty good. It's got a few little places in it didn't quite fill in, but all of them do. And what they're going to do essentially is this is a caged, more or less roller bearing. This is old stuff. This is like Model T old. But he's got some new ones coming, I hope. And yeah, a lot better than it was. So what rides on this is actually this guy right here. She's smoking still because I've brazed up the lip right there where it wore out. But I'll dress this up when it cools off, and this fits inside there. And that goes on something. I'm not exactly sure how all this stuff works, but there you go. That's how you can build a shaft up and use it again. Hopefully it'll last as long as as long as it did. So hope you enjoyed it, guys. That's gonna wrap this one up.